Hello everyone, so in this video we are going into the last part of 6.2 periodicity, which is ionization energy. So in this video we are going to focus on the definition of first ionization energy, and we should explain the variation of ionization energy across the period and down the group. So before we start, let's have a look at what first ionization energy. So by definition, it is the minimum energy required to remove 1 mole of electron from 1 mole of neutral gases atom. Okay, so this is the keywords. These are the keywords. So minimum energy untuk remove 1 mole of electron from 1 mole neutral gases atom. As you can see here, this is 1 mole of neutral gases atom to produce 1 mole of ion to release 1 mole of electrons. And this is what known as first ionization energy. Delta H is the energy lah. Okay, and the value for IE is always positive. Okay, first IE is always positive. Okay, because positif menunjukkan dia perlukan tenaga, dia akan absorb tenaga untuk remove the electron. Okay, so let's have a look at what the factors are that affect ionization energy. Okay, so let's say kita tengok atomic radius. This is one of the factor. Okay, the smaller the atomic radius, so atom tu lebih kecil. Kalau lebih kecil, ionization first IE dia. Okay, first IE, simbol saya guna IE1. Okay, is greater. Okay, this is because, okay, smaller atomic radius, because ionization energy is greater. As the radius gets smaller, okay, the valence electrons gets closer to the nucleus. Okay, so this is the explanation here. Okay, the attraction between the outermost electrons and nucleus gets stronger. Okay, therefore it is much harder to remove 1 mole of electrons. So this is the explanation dia. Sebab kalau kita tengok saiz makin kecil, elektron mestilah jadi makin dekat dengan nukleus. Jadi tarikan antara elektron yang dekat luar sekali dengan nukleus jadi semakin kuat. And because of that, lagi susah untuk buang elektron. Thus, the first IE increases. Okay, so this is the explanation for atomic radius. So if we look at the second factor, it is the effective nuclear charge. So the greater the effective nuclear charge, we can expect the greater the first ionization energy. This is because the attraction between outermost electrons and the nucleus gets stronger. Sebab kalau effective nuclear charge iaitu ZEF semakin tinggi, IE semakin tinggi sebab attraction makin kuat. And because of that, harder to remove the outermost electrons. Okay, thus ionization energy ionization energy, first ionization energy increases as effective nuclear charge increases. And then we look at the third factor, which is the shielding effect. As we know, shielding effect ni dia bagi size this, kalau shielding effect makin tinggi, okay, size akan jadi makin besar. And kalau kita tengok dekat size, kalau size makin besar, elektron jadi makin jauh lah. So dia berlawanan dengan yang ni, atomic radius tu. So greater shielding effect, the further, so kalau saya explain, the greater the shielding effect, the greater the further the outermost electrons. Okay, so if we want to explain this one, okay, so greater shielding electrons, the outermost electrons, okay, outermost electrons gets weakly attracted to the nucleus. So electrons, the outermost electrons, get further away from nucleus. Jadi it becomes easier to be removed. Jadi kalau kita punya shielding effect high, okay, greater shielding effect, we know that it is easier to remove the outermost electrons, thus i.e. first ionization energy becomes smaller. Okay, so these are the three different factors that affect the first ionization energy. So how does first ionization energy vary across a period? So here I have a chart. Kalau kita tengok dekat sini, so this is the energy per mole, okay, and for the first ionization energy from lithium to neon in period 2 and from sodium to argon for period 3. As we can see, it generally increases across the period. So ini adalah group 1, group 2, 13, group 14, 15, 16, 17, 18. 1, 2, 13, 14, 15, 16, 17, 18. Okay, so we look at this trend, we know that it generally increases. And we know why this is. Sebab kalau kita tengok tadi, the factor yang affect first ionization energy adalah atomic radius. And we know the trend for atomic radius across the period. Kalau kita go across the period, size semakin kecil sebab pizzas tu. Okay, so going across the period, proton number increases, effective nuclear charge increases, attraction between outermost electrons and nucleus becomes stronger. Okay, stronger. Jadi, because of that, outermost electrons gets attracted to nucleus more strongly. And because of this, because it gets attracted to the nucleus more strongly, harder to remove electrons. And because it is harder to remove electrons, i.e. first ionization energy increases. Okay, first ionization energy increases. Sama juga kalau kita nak explain down the group, as we know, number of shells filled with electrons as we go down the group, dia punya number of shells itu, and SAS tu, number of shells increases, and because of that, shielding effect pun increases. And attraction, sebab shielding effect makin tinggi, attraction between outermost electrons and nucleus becomes weaker. Weaker, sebab kita tengah cakap pasal strength, kita guna perkataan weaker ataupun stronger. And because of this, outermost electrons, okay, get attracted to nucleus more weakly. Okay, easier to remove electron. And because it is easy to remove the electron, first IE decreases. Okay, alright, so this is the explanation for the trend going down the group and going across the period. So now, kalau kita tengok balik tadi carta tadi tu, the graph, kita nampak ada anomaly ataupun keganjilan dekat sini. Semua naik ni, tapi daripada beryllium ke boron, nitrogen ke oksigen, magnesium kepada aluminium, phosphorus kepada sulfur, dia menurun. Ini menurun sedikit. Okay, why is this the case? Dia ada explanation dan kita boleh explain by looking at the electronic configuration of BE and B. So kalau kita tengok electronic configuration, kita explain kenapa boron, dia punya first IE dia lebih rendah berbanding beryllium. Kalau beryllium, dia punya electronic configuration is 1s2 to s2 dan Be plus is 1s2 to s1. We don't see anything weird with this. Kalau kita tengok boron, 1s2 to s2 to p1 adalah electronic configuration dia. Dan apabila dia buat B plus, dia jadi 1s2 to s2. Okay, now kalau kita tengok dekat sini, 2s2 ini adalah fully filled orbital. Okay, so B plus has a fully filled orbital arrangement. Which gives additional stability. Sebab kalau kita ada orbital arrangement, elektron dalam orbital tu penuh, dia ada kestabilan yang lebih sikit. Okay, dia ada kestabilan yang lebih sikit. Jadi kalau dia dapat lebih stabil daripada B nak jadi B plus yang lebih stabil ni, dia nak buat, they wanted to do that, because if they do that, they become more stable. Jadi it is easier untuk remove the electron. Okay, lagi senang, lagi mudah untuk buang elektron itu sebab dia nak jadi sesuatu yang lebih stabil. Okay, so this is the explanation. Okay, yang kedua pula, kalau kita tahu IE antara nitrogen dan oksigen, why does IE for oxygen is lower than nitrogen? Kalau kita tahu oksigen lebih lower than nitrogen. Okay, kita tahu electronic configuration again. Kalau nitrogen, it is 1s2 to s2 to p3. Kalau kita tahu oksigen pula, 1s2 to s2 to p4. Dan apabila dia jadi O+, untuk buat ni, dia punya outermost shell tu dia dapat 2s2 ni, dia akan dapat yang 2p punya orbital ni dapat 2p3. Kalau p orbital kita penuh adalah 6. Kalau separuh adalah 2p3. Okay, separuh dia p3. O+ has half filled orbital arrangement which gives additional stability. Jadi yang kalau half filled dengan fully filled ni, dia dapat kestabilan yang ekstra. Okay, kestabilan yang ekstra. Dan sebab dapat kestabilan yang ekstra tu, O nak jadi O+, dia suka. Sebab dia akan jadi sesuatu yang lebih stable. Okay, ni biasa je. Bila dia jadi O+, dia akan jadi lebih stable. Jadi dia akan nak jadi O+. Jadi tenaga yang diperlukan sedikit sajalah untuk capai stability tu. Dia memang nak sangat buang elektron tu untuk capai kestabilan yang ini. And kalau kita tengok nitrogen, ini dah half filled dah, stable. Nak buang ni jadi tak stable. So sebab itulah nitrogen lebih tinggi. Sama juga macam ni, yang ni dah fully filled, nak jadi half filled. Yang ni lebih stable, fully filled lebih stable daripada half filled. Okay, so dia macam itu. So that is the explanation that you need to know for the part of this chapter. And with that, we have finished the chapter 6, periodicity, ionization energy, and that is all for this chapter. So in the lesson tomorrow, we are going into the new chapter, which is chapter 7. So I need you to be able to watch this and then try to do the exercise that I will upload as soon as possible. And I will also expect you to answer the questions on your own and semak sendiri, and just ask me whenever you can if there are questions that you have. Thank you very much.